So brand new chapter. Everybody should be super excited about a brand new chapter, right? I kind of like that last chapter. Did you like it? Matrices. Got a lot of good grades. A lot of you guys had good grades on it. Not everybody, but there's a couple of hundreds, about two or three 98s on there. So that's not too bad. All right. So what we're doing today is something that's probably not brand new to you. All right. I hope it's not. All right. I hope it's something that you've learned before. We've actually, even when you had me for geometry last year, we did a little bit of this. We didn't get really deep into it, but we did a little bit of this. All right. So distributive property, everybody knows distributive property. So that's kind of what we're doing today. All right. Which is multiplication. And we're multiplying polynomials. What in the world is a polynomial? Okay. Well, poly is a prefix. Let me get this. For what? What does poly mean? Okay. Multiple or many. Okay. I usually say many. What's a nomial? I don't think the word is actually a nomial, but it could be a variable. It could be a. That could be considered a polynomial, okay? If you just put a number in front of it, that could be considered a polynomial, okay? If you did something like this, that's considered a polynomial. If you did something like this, plus 4ac minus 2, this whole thing would be considered a polynomial as well. Okay, this one just has one term, all right? Even if you put a 3 in there, that's still just one term. Well, I'll put a 3 right there too, all right? So this would be considered a monomial. You remember that from Algebra 1? Okay, mono meaning one, all right? The nomial thing, I guess, it means term. I don't know. I didn't do a deep dive to figure out where these words came from. But I know the prefixes, okay? So monomial, this would be a monomial as well, and this would be a monomial as well. This would not. Let's put one with 2 in there. What if I had 3ab squared minus 1? This would be a binomial, right? Because what you're looking at, the terms are all separated with a plus or a minus, all right? Is there any pluses or minus in between any of these? No, so this is just considered one term, all right? So the nomial thing is basically a thing that we call terms. Is that all right? All right, so that's one term, that's one term, that's one term. Even though there's 1, 2, 3, 4 different things in here, it's still considered a monomial because nothing's being added or subtracted to it. Everybody got that? But what about this? Let's go to this one. What about this one right here? This 3ab squared, that's one term. Even just a single number, all right, just a constant number, a 1, would be considered a term, all right? So how many terms do we have here? We have 2 terms. So what would we call that? A binomial, all right? And then this has how many terms? This has 3. So there's one term right there, separated by a plus sign, correct? Let me make that circle so it's not including the plus. Right there, and then right there. So we have 3 terms. So 3 terms would be considered what? A trinomial. And we're going to be using these words, especially trinomial. Binomial, not so much. Monomial, not so much. Trinomial is a huge thing that we're going to be talking about even today and throughout the chapter, okay? So trinomial is a big deal. So 3 different terms, tri. Now after that, we give up giving prefixes to them. We stop right there. We just call it a polynomial. So if you have 4 or more, we would just say it's a polynomial with 6 terms, with 10 terms, with 1,000 terms, whatever, okay? We're not going to be doing anything with 1,000 terms, don't worry. No. All right, so there you go. So we just a little bit of vocab to start us off. So what we're going to do, by the way, I did that vocab because of this. We're multiplying polynomials together. All right. Now, we're not going to, like 3a times a, you could consider that multiplying polynomials together. All right. Let's do that just for fun. What if I go 3a times a? What's the rule? Well, it's just 3. Then how do I multiply a times a? A what? A squared. Okay. Because it's a to the first, a to the first. What's the rule when you multiply? You actually add the exponents. Okay. If you have the same base, right, that a would be considered our base. If you have the same base, the rule is you add the exponents. Does that make it an addition problem? No, it's still a multiplication problem, but the rule says that you add the exponents. It's all Algebra 1 stuff. Agreed? Yeah, this goes way back. We're just kind of reviewing. This whole lesson, 5.1, is basically a review. Actually, the next couple lessons are a review of Algebra 1. If you took an Algebra 1 that taught you this stuff, and they should. Almost every single Algebra 1 class teaches this kind of thing. All right, so let's just do some examples. We'll spend the rest of the time doing some examples, okay? You didn't factor? Oh my goodness. Well, you're going to factor in this chapter. So, but we got to work our way up to factoring first. Okay, so we got to do multiplication first, and then eventually we'll do some factoring. All right, so this is 5x squared plus 3x minus 7. All right, so here we go. Again, we did this in geometry, so I know you've done this thing. All right, if this is a monomial being multiplied by a what? Trinomial. That's a trinomial right there. All right, you don't really officially have to know those words in order to do the problem, but it's good when we communicate with each other that we know what we're talking. We're speaking the same language here, okay? So in order to multiply a monomial times a trinomial, we have to do this thing. Do you remember this? Most teachers do this. All right, so we're going to take that 2x, multiply by the first term, and then apply whatever sign that you have. Then you're going to take that term, multiply it by the second term, and then you're going to take that outside term and multiply it by the third term. You've seen that with the arrows, right? Yeah, almost every teacher does that. So now let's go ahead and do it. Let's multiply these together. So it's going to be 2x times 5x squared. Well, when you have numbers out in front, by the way, what do we call those numbers that are out in front? We give it a special name. It starts with a C. It's not a constant. A constant would be just a number by itself, like that 7 or minus 7. That would be a constant. But if I had like a 3x, what do I call that? Coefficient, right? Coefficient. I'll write the word down. Everybody with me on that? All right. So that's our coefficient. Obviously, what is the x? Well, maybe it's not obvious, but it starts with a v. Right. That's our variable. Where are you going? Go ahead. All right. So now we know that. What if you had 3x squared? What's the squared thing? What's that? That's the exponent. All right. Again, just making sure we're speaking the same language. We good? All right. So now, if I'm multiplying 2x times 5x squared, first of all, we multiply the coefficients first. So 2 times 5 is 10. And then look what I got. I got x times x squared. What's the variable, or what's the exponent? Sorry, that's what I meant to say. What's the exponent for this x? It's a 1. If you don't see it, it's always a 1. Okay? And what's the rule we just talked about before? If I go x times x squared, you keep the base and you add the exponents. So that's x cubed. All right? Still multiplication. We're still multiplying, but how do you find the new base? You add them together. Does it make sense why? Because watch. X times x squared, or x squared. See, there's our x squared. X squared is x times x. Would you agree? So how many x's do I have here? I got 3, so it's x cubed. You understand why you add? Because this is 1, this was 2, 1 plus 2 is 3, so I got 3 x's there. All right, let's keep going. Plus, let's do this, 2x times 3x. So 2 times 3 is 6. X times x is x squared, not 2, squared, okay? We good? What's my next sign? This one's, you got a minus, okay? So put a minus right there. So now it's 2x times 7. So I just go 2 times 7, which is 14, but I still have to have that x right there. Okay.
Thank you.
And there you go. By the way, sometimes, not on this problem, but sometimes they may not be in order. So what if it looked like this? Okay. Like right there, that would be correct. Everybody watching? What's going on? What's going on? Up here. So watch. You could write the answer like that. It would not be incorrect. But it's not the way we write it, though. Okay, we always write it in an order, and they call it descending order. Ashton, make sure you watch the video, okay? So, descending order. I'm saying you wouldn't. Okay, that's my point, all right? Because they could have had the -7 in the middle and the 3x on the right-hand side. Okay, so if they would have had that and you multiply it through, that's what you would have ended up with. And that would be okay. I would give you credit for it, but it's not how we write it, okay? Let's write it the way, like you guys today, you text stuff, right, to each other, and your grammar's horrendous, your punctuation is non-existent, your spelling is ridiculous, okay? But you can still understand what the other person's saying, right? Would you agree? But you grow up, you become an adult, and you have to write papers for work or for a job or whatever you're doing. They're not going to accept text language, right? So even though they understood you, it's not the way that we do things. It's like this, okay? Even though that's the same thing, it's not how we do things. How do we do things? We put things in what? Descending order. From the highest power down to the lowest power. So which one's first? 10x cubed. Which one's second? The 6x squared because of the squared. And then which one's last? Minus 14x. Okay? So descending order is how you're going to do it. Write the answers. We good? Okay. Let's move on. Example 2. Now, this is a little different. What we just finished doing was a monomial times a trinomial. It was just distributive property. Well, this is also distributive property, but we got kind of like a fancy way of saying it and looking at it. And I'm sure you've talked about this. Every Algebra 1 student would have seen this. This is multiplication, right? This is example 2. This is multiplication, but look, I don't have just one thing over here multiplying by these two things. I got two of them, correct? So here's what I'm going to do. I'm going to take that first one, multiply it by everything in that parentheses, and then I'm going to take the second thing in the first parentheses and multiply it by both of them. I'm not going to put the arrows, that's too much. You get the idea, right? So it is distributive property, all right? But there's another way that math teachers like to show, and what they do is they do this. See how the first ones that I multiplied, the 3x times the x? So I would say it's the first terms, f for first. And then I'd go 3x times the minus 5. Those are the two that are on the outside, okay? Let me get to it, okay? So those are the ones on the outside, all right? So I put what? O for outside. These two are the two that are what? Inside, okay? So I'll put an I for inside. And then these two are the last ones that I do, okay? And then we call it FOIL, all right? Is there something like that in Spain? You probably don't use the word FOIL, though, do you? Do you use something else? What do you use in Spain? You just say distribute? Okay. So here, a lot of times, a lot of teachers, some books don't teach it, but it's actually in this book, okay, for FOIL. So a lot of people like to say first, outside, inside, last. Or some books say inner, outer. I don't know. I always said outside, inside. So that's the way I'll say it, okay? So the first terms, the outside terms, the inside terms, and the last terms. Okay? So that's just kind of an easy way. So when you talk to an Algebra 1 student, they'll say, you ask them about the FOIL method. Oh yeah, we did the FOIL method. Everybody knows, in America anyway, everybody knows the FOIL method because it stands for first, outside, inside, last. Does that make sense? In another country, they may use different letters and it wouldn't make a word. In English, it makes a word, so that's what we use, all right? But again, it's just like the distributive property. It's that first term times both of these, and then it's the second term times both of these. We good? But a lot of people like the FOIL thing. So let's do it. Let's do the first. 3x times x. What's that? 3x squared. Okay, the outside, the 3x and the minus 5. Always take in consideration the sign before the number. So what's that going to give you? Minus 15x. And then the inside, these two right here, they're both positive. So it's plus 2x. And then the last would be this one and this one. Again, it'd be a minus 10. Now, do we leave it like this and circle it? No, you always, and I mean always, simplify, okay, like terms. All right? If you have any like terms, you always simplify and add the like terms. There's no like terms with the x squared, is there? Because nothing else has an x squared. So we just write 3x squared. Now, these two are like terms. They have different coefficients, right? That doesn't make them different, okay? I should say this. It doesn't make them not like terms. It's the variable. You look at the variable. That has just an x. This has just an x. This tells you how many x's you have, and this tells you how many x's you have. So negative 15 plus 2 is what? Negative 13 what? X. So that means I got negative 13 x's. Everybody good with that? So I added my like terms. There's nothing I can do with that minus 10, so I just put down minus 10, and that is how we would write that answer. Is it coming back to you? Yeah. Good. Let's do another. This one we're going to do a binomial times a trinomial. So this is example 3. All right, so I'm going what? 6a minus 2. And I'm multiplying that by 9a squared plus 4a minus 7. Now, if you understood this being distributive property, this is the same thing. This is not a FOIL. What's the only time you use that FOIL? Is when you have two binomials, okay? So you're not really using FOIL here, okay? But you are using distributive property, all right? So after a while, you don't have to do these arrow things. I'm doing them at first because it's the first time that I'm teaching this to you guys. So I take the first one, multiply it by the first one, then multiply it by the second one, then multiply it by the third one. Then I take the second one in that parentheses, multiply it by the first, by the second, and then by the third. So let's write it this way. So let's do it. 6a times 9a squared. So do the coefficients first. 6 times 9, 54. A times a squared is a cubed. All right? Let's do that 6a times the second one. So again, 6 times 4, and they're both positive, right? So you put a plus. So 6 times 4, 24. And then a times a is a squared. And let's do it to the third one. 6a times negative 7. So it's going to be a negative 42. 6 times 7 is 42. And then what else do you have? What letter do you have? Just an a. Good. So that's the first one times that whole parentheses. Now, let's do the second one, that negative 2 times this whole parentheses. So it's negative 2 times 9, which is negative 18a squared. And then it's negative 2 times 4a, which is negative 8a. And then it's negative 2 times negative 7, which is plus 14. Do I circle that and that's my answer? I go on? Nope. Always look to see if there's like terms. Again, we're putting in descending order as well. Okay, what's the highest exponent that you have here? The a cubed, right, the 54a cubed. So we're going to write that. What I like to do when you start having a whole bunch of these that you're adding together, I like to mark them off once I'm done with it, all right? Just kind of, I don't know, it's just what I like to do. So watch, what do you have here? What's the next highest power? A squared, right? So let's look. Do I have any other a squareds? Yeah. 24 minus 18. So what's that? 6 plus, right? Plus 6, what? A squared. I'm done with that one, and I'm done with that one. What's the next one we do? The ones with the a's. So I got negative 42a minus 8a. So negative 42 minus 8 is negative 50, what? A. All right, I'm done with that. And you got one thing left over, the 14, and then there you go. It's in descending order. I've added up all my like terms. I did my multiplication. I'm done. It's not too bad, is it? When do we get out of here? Oh, we got some time, right? 5 after? All right, let's do the next one. If you look in the book, they do things just a little bit different. I kind of think it's not the best way to do it. Okay, I think what I'm doing right here is the best way to do it. So they approach it a little differently, get the same exact answer, okay, but I don't like how they did it. Okay, what they do is they put this on top of this, right? And it's like regular multiplication, right? Like if I had 375 times 23, if I had something like that, that's kind of what they're doing here. All right, they're putting one on top of the other. For polynomials, I don't like doing it like that. So I'm not even going to show you how they do it. All right, maybe I'm doing you a disservice. I doubt it. Almost everybody I've ever seen do it like this. All right, let's do another one. It's kind of like this. That's why I was looking at it, trying to figure out why did they give you two examples that look almost identical to each other? Because they're doing them two different ways. But let's just do it the same way, but two different problems. I'll go a little faster on this one since we've already done one like this. 3x squared plus x minus 4. So I would just do it like this. I've never really seen anybody else multiply it the other way. I mean, I've seen it in books. I just don't know what the advantage is to doing that. Maybe somebody watching this video is a math teacher one day, and they're going to look at it and like, yo, Mr. Hammy, you're missing out. But I don't think so. Can we do this without all those arrows? Let's try it that way. So what do we got? 2x times 3x squared, 6x cubed. 2x times x plus 2x squared. 2x times negative 4, negative 8x. Everybody good? All right, now let's do the negative 5 multiplied by that parentheses. So negative 5 times 3x is negative 15x squared. Negative 5 times x is negative 5x. And negative 5 times negative 4 is plus 20. Put in descending order, so the highest one is cubed, so 6x cubed. Let's do the 2x squared minus 15x squared. That'll give you minus 13x squared. Let's do negative 8x minus 5x. That's negative 13x. And then plus 20. And then there you go. Easy stuff, huh? All right. Yeah, man, I don't like the way that they're showing you how to do these examples. Okay? So, oh, stop your crying. I'm just showing you that this is how I would do it, and I think this is the best way to do it. I understand what they're doing, but I don't see any good reason for it. So let's do these. 3y, throw a y in there instead of x all the time. Now, this is going to lead you up to something that we're going to learn pretty soon. Is it the next lesson? Let me see. Solve by, factoring. Yeah, we're going to do some factoring. So it might be in the next lesson. What is factoring? We've said that word a couple times already today. What is that? It's this. Listen. What are factors? Like 3 times 2 equals 6. What is 6 called? The product. What are the two things that are being multiplied together called? They're called the factors. Okay? Everybody with me? So look at example 4. Which one is the product? The answer, right, the 6x cubed, blah, blah, blah. That's the product. Which ones are the factors? The two things that are being multiplied, right? So, maybe not on this one. This one would be a little bit difficult. But basically what you're doing is you're taking your answer and you're breaking it down into the two things that multiply to get this. It's kind of like it's like the opposite of the distributive property. That's what factoring is. So this one right here is one that we're going to recognize very easily, okay? But we're not going to do the factoring, but I want you to see what kind of answer we get. You guys watching? Hunter? Why aren't you taking any notes? Too cool for school? I don't think so. I think you should be writing this stuff down. We still got 20 minutes left, all right? It's not like class is over. So let's take a look. If we're going to do this, we could do FOIL method, couldn't we? Okay, or just think of it as distributive property, doesn't matter. So it's this times this. I'll do the arrows this time again. So 3y times 3y, 9y squared. The outside is negative 15y. The inside is plus 15y. What's going to happen there? They'll cancel out, right. And then I got this, positive 5, negative 5. That gives you minus 25. Now watch very carefully. Again, they're leading you up to something. You may not notice it unless I say something to you, which I'm going to, all right? But they are leading you up to something that we're going to talk about in the next lesson. I think the next lesson they do this. All right, so what do you got? You got 9y squared. Let's add like terms. These are like terms. That adds up to 0, doesn't it? Or, like Matu said, what? They cancel out. And then what's left? Minus 25. Okay? No, they add up to 0. They don't add up to y. Okay, so watch. Again, this is just a sneak preview. Okay, what we're going to do maybe Monday or Tuesday. I don't know when. What they're going to give you when they talk about factoring, they're going to give you this, and they're going to ask you to factor it, and you're going to have to come up with this. It's actually not that hard. Look at this. They're both the same except for what? What's the only difference between this one and this one? The plus and the minus, okay? Look at this. Again, this is kind of sneak preview. I'm not really supposed to show you this today, but don't tell anybody. Don't tell anybody, but I'm giving you a sneak preview. So look, do you see this minus right here? Okay? In order to get that minus, one has to be plus, one has to be minus. Would you agree to get that minus right there? If they're both plus, is there any way that's going to be a minus? No. All right, so if you got a minus right here, look at this. Look at this 9y and look at that 3y. What did we basically do? We went 3y times itself, or we kind of squared it, didn't we? How would you go backwards? Find the square root. What's the square root of 9? It's 3. What's the square root of y squared? It's just y. You put a 3y here and a 3y here. Okay? You got a minus, so that means one's going to be plus, one's going to be minus. And then check this out. This 25. How did you get it to be a 5? You square rooted 25. So this is what we're going to do tomorrow. But I'm showing you now. Well, you know what I mean. The next time we have class, you know what I meant. You knew I did not think that you guys were coming in tomorrow, okay? So look, stop. So look, what if I gave you this and I said to factor it? You should look at this and recognize, oh, this is that one with the minus in the middle and everything's being squared and everything's being squared here, right? We give it a name, actually. They call it the difference of two squares. What is the difference? It's a minus, right? Difference is minus. And is something being squared to give you 9 and a y squared? Yep. Is something squared to give you a 25? Yeah. So here's what you do. This is not on tonight's homework. This is just what's going to happen. I said this is sneak preview, okay?
No, but you said homework.
I know. I always give you homework. Why do you act surprised? So look, one's plus, one's minus. All right? You see that? You got a plus and a minus here. Because when I multiply them together, in order to get a negative, I got to have one plus and one minus. I can't have them both plus, I can't have them both minus. Now, how did we find out what goes here? Square root it. So what do you get? 3y here and 3y here. Then you look at this 25. That tells you what's going to go here. What is it? 5 here and a 5 here. So that's what we're going to eventually do with this. All right? But again, they're just trying to prepare you for what's next. I probably went way too much on that. Let's do another one. This is part B. Nope. Watch the video. I got to keep moving. So watch this. 3y plus 5 in parentheses squared. Now, I know what a lot of you have an instinct on what you should do here. Don't do this, okay? But I'm going to show you what a lot of students do that's incorrect. You got it? A lot of people look at this, oh, everything's being squared. So I'm just going to go what? 3y squared, which is 9y squared, plus 25 squared, which is, 5 squared, which is 25. You can't do that, all right? What are you doing? What does this mean? That means this whole parentheses is being squared. What are we doing when we square something? You multiply it by itself. So we need to write it. This is super important. Hunter, I hope you're getting this. All right, head down is not a good time. Look, please, just, okay, I'm not going to say anything. Just let's do this. So what does this mean to square something? You multiply it by itself. So we're going to rewrite it, 3y plus 5 times what? 3y plus 5. That's the first step. Do not, there is no distributive property with exponents. You hear me? You cannot distribute. You can't say, oh, 3y squared plus 5 squared. Nope, nope, no. You can't do it. All right? People do it all the time. They try to, but they get it wrong. I'm trying to save you that heartache. All right? When you have something that's being squared, you have to write it like this. It won't. Let's watch. Okay, so now I know how to do this. I'm going to do FOIL method with this, right? Or distributive property. So 3y times 3y gives you what? 9y squared. Well, so far it looks like it would work, correct? Right, you see it. Plus what? 3y times 5, which gives you 15y. And then you got another 5 times 3y, which is another plus 15y. It's not going to cancel out, is it? All right, plus what? 25. And now let's add like terms. 9y squared plus what? 30y. See that? It doesn't go away. It becomes a 30y plus what? 25. All right? So there you go. This is another one where they're going to ask you to factor. Okay, I'm not going to get into that one. It's a little bit more involved than the other one was. The other one was fairly quick to see, pretty easy to see. This one's a little more complicated, but you are going to take something like this and have to turn it into this. All right? Got another one like this, or something like it. Let me see. Yeah, the last one. This is the last one. It's basically the same thing, except it's a minus instead of a plus. All right? So it's basically the same thing. So first of all, what do? What's our very first step? Write it twice. Good. I like that. Write it twice. So that times this. Everybody see that? All right, just like we did here. Do not, I can't stress it enough, just because I see so many students do this all the time. They go 9y squared minus 5 squared. Okay? It does not do that. So watch. We've basically done this already. We've got different signs, though, this time. So what's this going to be? 9y squared, and then minus what? 15y, and then minus 15y, and then plus 25. Okay? 9y squared. What happens here? It's minus 30y. Does not add up to 0, does it? Okay, and then plus 25. That is your answer. Like I said, eventually, on Monday, I believe, again, I haven't even looked at that next lesson yet, but at least in the next 1 or 2 lessons, they're going to have you take this and make it look like this. All right? But all you have to do right now is to get that as the answer. And that's all you got to do. We good? kind of nice just to refresh our memory. You did all this stuff in Algebra 1, didn't you?
No.
Sure you did.
My Algebra 1 class was a joke, but I remember this.
Yeah. So this is section, what is it, 5-1? And 1 to 31 odds. Odds. Okay, that makes it a lot easier. Yeah, you don't need to do 30 of those problems, 31 of those problems. Just do about half of them. All right, so section 5-1, just the odds. Everybody see that? So what are the odds? 1, 3, 5, 7, 9, ... Okay? Everybody with me? All right, get those done. You got an extra day. I'm sure you're going to spend your day off doing your homework, right? Of course. So there's no... be a good idea, right? You got nothing going on tonight. Get it done tonight. Okay. Get it done tonight. And then you won't have to worry about it the rest of the weekend. All right, that's it. We'll see you on Monday.